go. Thank you so much for that kind welcome. So I'm here today to give you a slight introduction to Elm for React developers. It's just a small taste, and probably it's something different from everything you do in your daily work. So this is that one talk where you go outside of your the stuff you do in your day job. So how many of you have heard about Elm? Quite a few hands, that's good. How many of you have heard about a guy called Jonathan Ive? Quite a few. So Jonathan Ive is the chief designer at Apple. And he can be said to be one of the most influential people in the development of all the modern Apple products after Steve Jobs. And I have this colleague who's a big Elm fan, and he has this quote that I really love. It's a bit pompous, but it kind of hits the nail on the head. And he said that Elm is like Jonathan Ive designed a programming language. It's minimalistic, it's user-friendly, and it just works. And then we can start discussing if that still applies to like the new Apple products or just in the old days, but that's a different talk. So I have some rhetorical questions for you. You don't have to raise your hand, just think inside of you what the answers to these questions are. So did you ever ship an app with confidence that it would never crash in production? Good for you. For me, no. Did you ever feel completely safe after a large refactoring of your front-end code? I worked at a client once that they had like 3 weeks of regression testing for every major release, or every release really. So you can imagine how often they were able to push to production. Did you ever become overwhelmed by the amount of front-end technology that you have to learn? I mean, Michaela touched on it. You have like React Redux, React Redux Router, etc., etc. And maybe you ever felt like not all of your team members were comfortable doing front-end tasks and touching the front-end code. At least for me, I've always worked in teams where there's some people who love the front-end and JavaScript, and there's some people that would never enter the JavaScript world. So for me, working full-time as a JavaScript front-end developer, I can safely say that all of these points are true pain points that I've felt during my career. And one of the reasons I like Elm so much is because I think that Elm addresses all of these issues to some extent. And I will try to show you how in this talk. So who am I to have some thoughts about this? Why should you care about what I say? So my name is Erik Wendel. I'm from Norway. I work in Oslo in a consultancy with about 450 people. And after talking to Cesare, I've discovered that consultancies in Norway and Italy are quite different. We are about 350 technologists, and we do mostly large-scale projects ranging over several years. Doing a lot of stuff for the Norwegian iOS company, for like the Norwegian welfare company, banks, lots of different stuff. So I specialize in user interfaces, working previously with JavaScript and now more and more with Elm. I've also founded the Oslo Elm Meetup group and Oslo Elm Day, which is a one-day conference similar to this one. So today's agenda looks like this. I'm going to show you how Elm works and just touch the surface. And I'm going to compare Elm to what you guys know, which is React, and hopefully you know some Redux as well. Then I'm going to do something that never fails, and it's completely safe. I'm going to try to live code a little bit for you. But don't worry, I've done it 2 times before, so hopefully that will work out. And lastly, I will discuss a little bit, does anyone actually use Elm in production, or is it still just a toy? So let's dive into Elm. So Elm is a language compiling to JavaScript. So it's not another library, it's not another framework, it's a totally different thing. And when you have a language, you have so much more control over your runtime, over your entire development experience, so you can make larger promises to the developer. You can go farther. So in a way similar to what Apple has tried to do, they take full control over the software, the hardware, the App Store, just the entire experience. Elm tries to do something similarly. They can promise you more by taking more control over the way you code. And Elm is a functional language, so it doesn't look very much like JavaScript. So basically, Elm and JavaScript are totally different, both in terms of syntax and semantics. Because of course, if you're going to go far in your promises, you have to make some drastic measures. You can't just give someone like a 100-line library and expect it to change their world, right? So that might be a bit of a learning curve for a lot of people. So Elm uses pure functions and virtual DOM to create a tree of components. Sounds familiar, right? Basically the same as React. So the view model of Elm will seem extremely familiar to someone familiar with React. But on the contrary, Elm does not allow component state. So there's no local state in your components, there's only this big blob of data on the top of your tree, like with Redux, but with no local state. So basically Elm uses the Redux architecture. But the cool thing is that it's actually the other way around. So Redux is using the Elm architecture. Because Dan Habermal looked at Elm a couple of years ago, thought it was really cool. Let's try to do this in JavaScript and adopt the time traveling mechanism. So I would say that Elm is basically React Redux with type safety. And that's also a claim with some modifications, but it's mostly true. So I would say that Elm is, at least to me, more like the next step of what we do today. I love React and Redux. I think it's so much better than all the alternatives I've used in the past. And to me, Elm is basically just more of that way of thinking. It's based on functional programming, it's based on the virtual DOM, and this big single source of truth where we have all your data. So if it works like React, etc., Elm will compile to a JavaScript file that you will import in your code, and it will expose one global object, the Elm object, and then you can say to Elm, please render this app into this DOM node, just like you do with React, right? So it's very easy to use Elm on a small part of your app. Basically the same React story all over again. So a quick overview of the language. Correctness, maintainability, and developer friendliness comes first. That's the main focus of the language, making it a nice experience for us, developers, to be coding applications. And when I say correctness, I mean that your code will run without errors and hopefully also produce the correct result. So it's a language of the ML family that's similar to Haskell, F#, or Camel, and those languages were originally used for doing mathematical proofs. So they're very, it's very important in a lot of languages to produce correctness. And that's why Elm can, in some way, deliver a promise of no runtime errors. Your code will simply not fail in production. You can produce the wrong result. You can do -1 instead of +1. But that's a logical error, it's not a runtime crash. And it's very opinionated. To achieve all of these promises that Elm wants to make to you, the developer of Elm has set a large box of constraints that you have to work under. So it's very heavily opinionated. Some key language features is that all data is immutable. You simply can't have mutable data, and there's no null, and there's no undefined, which means that there's no null pointers, there's no undefined, it's not a function, there's no, all of those errors just go away, simply. And it's an expression-oriented language, there is no statements, like an if sentence in JavaScript doesn't produce a value on its own, it just decides should we run this line of code or not. But an if sentence in Elm is more like a ternary. The expression in itself is a value, as I will show you later. Everything evaluates to a value. So Elm is a pure language, so you can't have side effects. So you delegate all the side effects that you need to do to the runtime. So this resembles Redux Saga, largely, where you say to Elm, please do this Ajax call for me, or please generate this random number, because I won't do it myself, because then I would breach the pure function thing. And architecture is just built in. It uses the Redux architecture, as most of you know. You don't have to decide how will I architect my Elm app, because all Elm apps have the same architecture. So for me as a consultant, if I enter a new Elm program, I know that I will be familiar with the way the code is structured. And lastly, but not leastly, it has a very small but expressive feature set. So it's not a very large language. You can basically skim all the different constructs in a very short amount of time, as opposed to JavaScript or even larger languages like Scala or C++ that are just huge. And this makes it pretty easy to learn all the features in Elm pretty quickly. So let's see some code. So since Elm is a functional programming language, functions are at the core of Elm. So this is how we create a function increment that takes one parameter x, and it returns x plus 1. And 5 is a constant, which we would call a variable in JavaScript, but it can't change, right, since everything is immutable. So 5 is a constant with a value of calling increment with 4. So instead of using parents to call a function, you're using a space. So whenever you see something, space value, all of those values are just parameters to the first thing. And Elm can infer all the types, so it knows that x would have to be an int because the plus operator only works with ints. So therefore x must be int. But for good practice, we still declare all the types because it's documentation for the next developer reading your code, and it's basically a message to the compiler to say that, hey, I'm going to write this function, I want it to work like this and this, but if you manage to do something wrongly, the compiler will tell you there and then. It won't try to assume that you were trying to return a string because you said in the type declaration that it should return an int. So we have constants to store data. We also have tuples. We don't have that in JavaScript, but you do in Python and some other languages. And then we, of course, have ordinary objects like in JavaScript, which are called records in Elm, but I'll refer to them as objects for familiarity. So here we say that person has type object with field name of type string and field age of type int. So this is similar to what it would look like if you use TypeScript or Flow, right? You would denote all the types on your values. You don't have to, but you should. And then you have something called type aliases to introduce new types in your code. So you can say that coordinates, that's basically whenever we have a tuple of ints, let's just call it coordinates instead because that's easier to read. You can also say that whenever you have an int, let's just call it a discount because a discount is basically stored as an int. So we just alias a type with another name. So let's say we have a customer type, which is whenever we have an object with this shape. So it's not like a class or a constructor like in Java or C#. Basically it's saying that whenever we have something that looks like this, we might refer to it as a customer. But let's say every customer has a customer type. So we add a type field, and in JavaScript that would probably be a string. So let's say that that type field can be either student, corporate, or just like a private customer, a person. So the student type needs a student discount, which is stored as an int. Okay, that's pretty straightforward. Student discount 50 when I was a student. But then I age a few years and I start working at my current company, and now I'm a corporate customer. So now I have 0 student discount, which is true because I shouldn't have a discount, but I'm not a student, so why is there a student discount field there in the first place? Doesn't make sense. So we have this mechanism of modeling this that's just incredible. It's the first thing I miss when I go back to JavaScript or many other languages. And it's called union types, or sum types, or discriminated unions, or has lots of different names. So it resembles a enum type. So you're saying that this customer type, that's a bad name, I know. It could be either student, corporate, or private. Those are the possible values. It can't have another type, it can't be null, it has to be one of those 3 types. But here we lost the student discount and we lost the corporate name. Because when I am a corporate customer, I need a company name, which is a string. So we can just add those. So whenever we have a student value, we need to give it an int. If you don't do that, you won't get the student value back. It's not possible. The compiler will have your back. So it's not possible to make that error. Similarly, for whenever you have a corporate value, you have to give it a string when you create that value. You simply can't have a value of the type corporate without it wrapping a string or containing a string. It brings with it some data. So when we try to unwrap these and use them in the other end, we'll use what's called pattern match. So here we have a function getDiscount that accepts one of these customer type values, and it returns a discount, which is an int. So here we use the case expression, which is one of the few constructs in Elm. We say that, okay, we want to switch depending on the value of this class. So it's basically like a more fancy switch statement. So if it's of type discount student, then execute this line, etc., etc. And it will implicitly unwrap the type that the value is carrying. So if you have a student value, it will contain an int, because we say so up here. You don't need to explicitly state the type here, because it's a given. So here, if you add another customer type, the compiler would just simply refuse to compile your code if you forget to handle it in the case expression. And that's a pretty huge deal. Whenever you try to refactor a large code base, you will be changing these all the time. I mean, you model like the actions in the Redux system with it, and you basically model a lot of stuff with it. And also you have type level security on the different branches. So that's a huge win. And we use these union types to get rid of null. That's the null killer of Elm. So we use something called a maybe that has two branches. You can either have just something represented with an A, which is a type placeholder, or you have nothing. So whenever you could have null, like either we have a student discount or maybe we don't, we'd say that we just have an int or nothing. And then when you're going to use that thing, then you will be forced to unwrap it using the case expression, and Elm would force you to say, what are you going to do if it's not there, right? In JavaScript, it's so easy to forget. You'd have to do so much unit testing to make sure that all of those possible error cases are impossible. But in Elm, the compiler will have you back. It's simply impossible. So I could give like a tough refactoring job to like a summer intern, and if it compiles, I would know that it would not crash. Of course, you can have like logic errors, but that's what the remaining unit tests are for. So let's move on and look on a bit of HTML. So this is a bit of HTML, which will be created by functions in Elm, similar to React. So this is pretty similar to what happens under the hood in React when you don't use JSX, or after the JSX has transpiled. To create a div, you would call a div function with two lists, a list of all the attributes. So class is a function that accepts a string, and it will create an attribute. And the second list of children. So this is only has one child, which is a span with no attributes, and a text called banzai. And the reason you need to call a text function is because you can't just output a string to the DOM. You need to wrap it in a text node, which is an HTML technicality. So you also need to be able to interact with the HTML. Let's say you have add an on-click handler. You just use the on-click function to create an attribute, and you give it some value. And here's where Redux knowledge comes in. So you're basically saying to Elm that whenever you click on this span, create this value for me and input it back into the system. So that's like dispatching an action in Redux. So the Elm architecture should be very familiar to a lot of you. We need to represent our app state in a way. So we create a type alias called model. And we need to represent that data as HTML, which is our tree of React components in the React world. And that function takes the model, and it returns a tree of these HTML function calls. Update represents the root reducer in Redux, like the sum of all possible changes to our model. So that function accepts something called a message, which is a union type representing all the different things that can happen in our application. And then we are given the previous model and the next model. Lastly, we also need to be able to do side effects, which is called subscriptions. I won't go in detail in that today. And it's possible to interrupt with JavaScript only through ports. That's the only way we can do that. So you basically use a string, you pass strings through like a message passing system to the JavaScript code, and then you can subscribe the other way around into Elm. So this is a simple example where we store something to local storage. So we have a port called save token, and we subscribe that whenever Elm passes some data to JavaScript, we just save it to local storage. And whenever Elm calls the load token function, we will do this. So it's a bit cumbersome to work with JavaScript, but that's basically because whenever you work with JavaScript, things can fail. So you want to stay inside of your safe little Elm bubble as long as possible. But of course, you have to interrupt with JavaScript at some point. So let's look at the libraries you would have to use to get this out of the box in the JavaScript world. You'd need React for the virtual DOM and all of the view layer. You would need Redux for the state management. You would need immutable.js to get immutable data. But then again, it wouldn't be that hard for like a new developer on your team to simply just not use immutable and just create a simple mutable object and not realize the difference. And then you have a bug, right? You'd have to be there and make sure that don't happen. In Elm, everything is immutable. And you'd need TypeScript and or Flow for a considerably weaker type safety. It's so much easier to just pull the escape hatch, and then you're free. You can do whatever you want, and you can make your app crash unknowingly. So basically, you can achieve a lot of this in JavaScript, but you have to really make sure that you know what you're doing and realize that you're not perfectly safe. And lastly, you would want like ESLint or some other code sanity tools. So I'll try to live code a small example for you. I'll try to create a counter application like we've all seen before, like the arch example of Redux, where you have two buttons, and clicking one button will increment the number, and the other button will decrement the number. Actually, I think I won't have time to actually live code the entire example, so I think I'll just run you through the code. I mean, you don't get that much joy out of watching me type anyway, so that's that. So this is the model, which is the thing that basically holds all our application data. So in this application, we just need an int, right? But in any ordinary, like real-life application, this would be a large structure of organized data. And then we're saying that, okay, here's a constant called model. It has the type model that we made up here, and it starts with the value 0. Pretty simple. Then we have our view function, which accepts the model and returns the HTML. So here we simply create a div. It has no attributes, which is why we have an empty list here. And it has one button, and we take our model, we toString it, and then we pass it to the text function. So this pipe operator is basically the same as doing this. First we need to pass the model into the toString function, and then take the result from that and pass it into the text function. And I think it's much easier to read this once you get used to the pipe operator, which originates from F#. And it's actually a proposition in JavaScript now to add this to a future version. So it's on GitHub. You should start it, it's really good. Here we say to Elm that, okay, whenever you click these buttons, trigger the action type, or what we call a message, of increment or decrement back into the system. And here's our type defined as a union type. So you can immediately, when you see this code, know that the only things that can happen in your app, the only interaction possibilities, are the increment and decrement. So whenever you see a new Elm code base, just find the message declaration, and you can see everything that's supported. Like, do we support the user timeouts? Just check the message. If it's not there, you have to make it yourself. And then we have the update function. So here we use a case expression to see, okay, what happened? What type of message was triggered back into our system? Was it we got the data from the server, or the data fetching from the server failed, or was it increment, or was it decrement, or whatever? And lastly, we have what we call the beginner program. There are two main program types. There's a beginner program that's free of side effects, like this one, or this is the more professional one, where you also can tell Elm to do Ajax and other stuff for you. So what I would also like to point out is that the main function is the only place where you actually output something to the DOM. So what you have here is that's the only place you can output something. So whereas in a JavaScript program, every line of every file can potentially do like a document query selector and go and modify things, right? You would never know. But in Elm, this is the only thing. The output of the view function, that's the output of your app. It's as simple as that. And I'd like to show you one more thing, because there's this program called Elm Format, which is basically the inspiration, or one of the inspirations for Prettier. So let's say I would write my code in a different manner. I would like to do this. I'm not sure how I format Elm code, so I just figure it out by myself. Then whenever I save, Elm Format would basically just say, hey, do it like this. It's nice. It's what everyone else does. So whenever you open a new Elm app, you have the same architecture. You have the main function being the only thing that can output something to the DOM, and you have the formatting just being fixed for you. So I think that's very nice. So let's head back to the presentation. In a long version of this talk, I'll also walk you through this app, which is a memory game, but the code is online. I'll just refer to it at the end. If this made you curious, go and check that out. It's also a workshop that you can code if you want to try to learn Elm for yourself. So, does anyone actually use Elm? So Elm has been around for quite a few years, generating a lot of talks at conferences and attention, blog posts, etc. But is it really ready for production? I mean, that's the most interesting thing if you think the idea of Elm is interesting. So if anyone is using it in their business-critical, user-facing apps, what's their stories? So that's what I asked myself last year. So I wanted to gather the Elm community in Norway. So I made the Oslo Elm meetup, which had a huge interest without any marketing. Within a month, we had like 150 members, and mind you, Oslo isn't the biggest city. And now, after a year, we have almost 400 members. We have a monthly meetup. So I try to talk to all the people there and see what they think about Elm, do you use it in your projects? And it's actually turning out that a lot of people are using it, as I will tell you about in a minute. And I also thought, hey, let's just make a conference. Because one of the biggest names in Elm, called Richard Feldman, working in California, he was coming to Paris for another conference. So I just said, Richard, do you want to come by Oslo on the way home? Sure, why not? And then we had to do something with him coming, so let's do either a large meetup or a conference. And we just went for it. So we got around 155 people coming from the area, and 10 speakers from 5 countries. So I really could feel by then that there's a lot of attention around Elm. So we want to walk you through just 2 of those apps and tell you why those projects decided to use Elm. There's a lot of more projects, but I only have 30 minutes today, so I'll try to be brief. So this is a photo from a conference in Oslo called JavaZone. It's not just about Java, it's a really crappy name, but it's so famous in Norway and Scandinavia, so they just decided to stick with it. They have around 3,000 attendees, and it's just a non-profit. There's just people like you and me doing all the organization, writing all the apps and all the systems and stuff. And this information screen, that's about 7 by 10 meters, and there's 2 of them, so they're just huge. And that was run by this old Backbone.js system. And one of my friends is working as a volunteer for the conference, and he was given the task to refurbish the code. So I was thinking, okay, so if I do this in React or some new system, and if I manage to screw it up, then there will be 7 by 10 meters times 2, so that's 140 square meters of all my friends and clients seeing my code fail. So let's try this new Elm thing, just for fun. And he did, and they actually are really happy with it. Even the more back-end hardcore dudes at the conference are actually working in the code because you have the compiler and it will yell at you if you do something wrong. So it feels safe. It feels more like the things they do in their back-end. And secondly, it's my own project. I currently work for the Norwegian Railway Company. So we had a couple of summer interns who are doing their 3rd year in university. So we tried, let's give them a challenge to write an app in Elm and see if they cope with it. They have no prior experience. I mean, if they can learn Elm and produce an app in 6 weeks, then it should be a pretty good fit for more experienced people as well. So we gave them the task of creating the app where you choose your seat when you reserve a ticket. And they did, and they really loved it. The only complaint they had was that they had to spend too much time doing the iOS and Android code, so they didn't get to do Elm full time for 7 weeks. So I guess that's a pretty good conclusion. And also, our team has a lot of people that are not familiar with JavaScript at all. If we did a React Redux front end, I knew it would work, but those people would never touch it. It would be me and 2 other people doing all the front end code. But those 3 others are really keen on Elm because it's a compiled language, it has a great type system, and they would feel more comfortable. They didn't have to learn all these different libraries and frameworks, they would just learn Elm, and that would be it. So, a quick summary of all the people I talked to. There's a lot of people experimenting and using Elm actually, but there's no really huge projects yet. So I'm anxious to see that pop out. And 100% of them are saying would use again. And that's a pretty big deal. And that's just not something I'm saying. I didn't selectively ask the people that I know like Elm. I asked all the people I could find, and they would all use it again. And the onboarding is pretty easy, especially for React Redux familiar developers. And the world's biggest adopter in California has about 150,000 lines of code of Elm in production. So don't use Elm if you're making a prototype, or speed is more important than quality. I mean, if you're a startup, you just want to get features out, and you don't care if the features live for a lot of years, just to get it out there. Maybe Elm isn't the best fit. If you use a lot of third-party code that you can't just integrate very easily with to the ports, maybe Elm is a bad fit. And if the team doesn't know any functional programming and aren't at least interested in learning a little bit, I mean, Elm is one of the easiest functional programming languages there are, then maybe also Elm is a bad fit. But Elm is a great fit if you know the big refactorings will be coming, you know that you don't know what you're actually creating, you know that you will have to refactor a lot. or if you have a complex domain logic that the type system can really make you sleep better at night with. If code correctness is very important, or if your team basically don't know a lot of JavaScript, or they don't want to learn a lot of JavaScript. So, I hope that I have explained properly now how I feel that Elm addresses the JavaScript fatigue, the worrisome refactorings, dedicated front-end developers taking all the front-end work, and really nail-biting deploys. So, I think I'll skip this short summary, as I guess you're starting to get the point now, and I'm out of time. So is it a good deal? I mean, is the value given by Elm enough to like outweigh the bad parts? I think so. We have Elm in production, as more and more is coming, but that's really not important. The important thing is, what do you think? So I hope I've been able to make you a little bit curious, and if you are, please check out my free workshop material, or any other material for that matter, where you can just code some Elm with a guide and make something for yourself. Join the Elm Slack team. There's a lot of really friendly people on there. They have like an open goal of answering every question there is on the open challenge. So if you have a question, just go on there and ask it, or ask me. I'll be happy to help you. And please follow the Oslo Elm Day if you would consider coming to Oslo to listen about Elm. We'd love to see you guys there. And that's it. Thanks for listening.